Hey guys, welcome to part two of the ACP review packet. We're going to pick up where we left off from part one, which is on number 12. A kicker in a football game attempts a field goal 50 yards from the goalpost. The ball is on the ground and is kicked with an initial velocity of 81 feet per second at an angle of 66 degrees. The height of the crossbar on the goalpost is 10 feet as shown in the diagram. For the field goal to be good, the ball must pass over the crossbar and between the uprights, assuming the kick is straight and passes between the uprights, which conclusion is true. So the first thing we can do is draw a little coordinate plane where this is going to be taking place. So there is a kicker with a football. And the question does say that the field goal is attempted 50 yards from the goalpost. So that means the kicker is right here and 50 yards away is the goalpost. So that means that horizontal distance will be 50 yards. The ball is on the ground. So at first glance, that doesn't seem that important. But ball is on the ground. That will be the initial height of the ball. So it would be different. Let's say if he had the ball in his hands and he was going to throw it, then the initial height would be something else. But it does specify that the initial height is on the ground. So since there's no height, then it has to be 0. So I'm going to put h sub 0, h for height and 0 for initial. And then we keep reading is kicked with an initial velocity of 81 feet per second. So the letter we use for velocity is v, and then for initial it's 0. So initial velocity is 81 at an angle of 66 degrees. So theta is 66. The height of the crossbar is 10 feet. That's already given to us. And then let's look at the choices. So the ball hits the ground before reaching the goalpost. So that means that he kicks it and it lands like on the ground, or it passes under the crossbar. It says it could go over the crossbar and the field would be good. And then answer choice D is that it hits the crossbar, in which case if it hits right there, then it just hits it and falls back down. Okay. So in all these answer choices, notice that the height has to be if it's less than 10 or equal to 10, it's not going to work. It has to be greater than 10 feet in the air in order to go through over the crossbar. So how are we going to figure this out? So we have these variables: initial height, initial velocity, and an angle. Let's say you're taking the test, you have no idea what to do. Analyze your formula chart until you see something that has those variables: initial height, initial velocity. I'm looking. I already know where it is. That's why I'm looking so fast. But it's projectile motion, okay? So we're going to do the vertical position and the horizontal distance. So you got x equals t v sub 0 cosine 0. So we have some of that stuff. So I'm going to come back over here and we're going to write these equations. Now on the calculator, you do have to put the time symbol in between everything, otherwise it's not going to work. We don't know t, so t is time. It doesn't say how long the ball is going to be in the air, so just leave it as an unknown variable. And then, so you should have your formula chart in front of you. The next thing is initial velocity, which is 81, times cosine of the angle, which is 66 degrees. Then for y, it's set up very similar, but instead of cosine, you're going to do sine. And then on top of that is minus 1/2. And then pay attention on the formula chart is the letter G. Now, if you're familiar with physics, you know G usually stands for gravity. Gravity is right here on the formula chart, and notice that there are two numbers. If your units is in feet, you're going to do 32. If your units are in meters, you're going to do 9.8. And it just depends on the question. So on this question, we are at feet per second. So if you look right there, the velocity was given in feet per second, and the feet per second one is right here. So the gravity that we're going to use is 32. And again, I'm just putting the time symbol because if you don't put the times in the calculator, it's just not going to work. And we don't know time, and then plus the initial height, which is 0. So those are the two equations. So at first glance, you probably can't tell, but this is a type of parametric equation. That's because there are three different variables going on. So there's the horizontal distance that the ball is going to travel. Then there's the vertical position of how high the ball is going to go. And then how long is the ball going to be in the air? So those are three different variables happening. So let's go to the calculator. And you're going to open up a graph. And then you're going to do menu, graph entry, and then parametric. And then in there, you're going to type exactly what we had in the packet. So T times 81 times cosine 66. Notice that 66 is in degrees. Go ahead and make sure that your calculator is in degrees. Right now, I was in radians. So your angle is in degrees. Make sure you're in degrees. Okay. Oh man, I deleted it. That's fine. I'll retype it. T, where'd it go? Oh man, what is happening to my... Okay, let me start over. T times 81 times cosine 66. And then for y, we have T times 81 times sine of 66 minus 1/2 times T squared plus 0. The parameter interval, you can leave it as a default. You don't have to... Oh man, I forgot the 32 in here. Times 32 times d squared. Okay, enter. When you get here, you're going to be too zoomed in. So do menu, zoom. I like to do zoom fit, but you can do zoom out. So zoom fit, it shows you in one click, really just shows you the whole entire graph. So what are we even looking for? So if you remember from the question, the guy is 50 yards away from the crossbar. So essentially, we're looking for the coordinate point where x is 50 yards away. And then we're looking for the y coordinate because we want to know, is it going to be over 10? It cannot be equal to 10 because if it's equal to 10, it's going to hit here and fall. Okay, so it has to be 11 or higher. So that's what we're going to go look for. So how are you going to do that? You're going to do menu and then trace and then graph trace. And then at the very bottom, it's kind of cut off on my screen, but that's okay. At the very bottom, you see the x and the y coordinate and t equals 0. So you're going to click to the right and notice that my x is increasing. We got 6, 9, 13, 16, and you're going to keep going until you get to 50. Now, it's not going to be exact. You're going to get an approximation. So notice that from 49, it jumps to 52. But between there, we got 75 and 77 for the height of the ball. So 75 and 77, that gives you a pretty good understanding that it's going to be way higher than the minimum 10. So that ball is like this. It's like 70, 75, maybe 76 meters, feet. 76 feet up in the air. So it most definitely went through the uprights. And so for that reason, the answer would be C. The field goal is good. Moving on to number 13. The co-vertices of an ellipse are at -2, 1, and 8, +1, and the eccentricity is 12, 13. What is the equation of this ellipse? I always like to start by graphing. Some of you guys are visual learners, and it helps. If you can do it in your head, that's good for you, as long as you don't make any mistakes. So here we have -2, 1, 8, +1. And these are the co-vertices. So this is a co-vertex, co-vertex. You want to read carefully. Don't always assume they're going to give you the vertices. So from co-vertex to co-vertex, you have the minor axis. Oh man, from here to here. Why is it doing that? Sorry, I'm wasting your time. Whatever. Okay. From co-vertex to co-vertex, you have the minor axis, and the minor axis is equal to 2b. So from -2, so you got 2 units this way, 8 units that way, so for a total of 10 units. The semi-minor is when you cut the minor in half. So half of 10 is 5. When you have that, you're able to get the center. So the center is going to be here. So from co-vertex to center, you're gonna have 5 units. So you can add 5 to -2. So -2 plus 5 would be +3. Or you can subtract 8 minus 5, which is 3 anyway. So regardless, you're gonna get 3. And notice that the y doesn't change. It stays at 1. Okay, so this is the center. Now, if the co-vertices are horizontal, that means the vertices, the legit vertices, are vertical. And the ellipse is vertical if the vertices are vertical. So since the vertices are vertical, then this is going to be a vertical ellipse. Okay. Let's see what else we can figure out. So it gives us the eccentricity. So if you remember on your formula chart for eccentricity, that's E equals C over A. So I'm going to come back over here and do E equals C over A. Well, the eccentricity here is 12 over 13 equals C over A. And they basically just gave them to you. C is 12, A is 13. So that's all we need to write the formula. Now, this is a vertical ellipse, meaning we're going to be using this standard form. Remember, if it starts with H, it's horizontal. So this one is going to be for the vertical ellipses. So y minus k, which is 1 squared, over a squared, which is 13 squared, and 13 squared is 169, minus x minus 3 squared over b squared, and b is 5, and 5 squared is 25. And then so you would match up the answer choice. They put x first, so look for the one that's x minus 3 squared. So the answer choice would be C, as in cat. X minus 3 squared over 25 plus y minus 1 squared over 169 is equal to 1. Okay, let's go on to number 14. Which polar equation produces a spiral of Archimedes? Number A, we didn't really go over that, but this is basically a straight line. If it's theta equals something, it's going to be a straight line. And that's not a spiral, so you can eliminate that one. Now, if you remember how to graph, I'm going to open up a new graph, and you do menu, graph entry, and you're going to do polar, because this is the polar graph. Notice that it's R1 theta, meaning you got to put R equals. B and C are not R equals, so you're going to need to solve for R so you can actually graph it. So what you could do is divide both sides by cosine, and so you would get 2 over cosine theta, and the same thing for the other one, it would be 2 over sine theta. The last one is already in R equals. So again, the calculator steps are menu, 3 for graph entry, 5 for polar. You need to make sure that you are in radians. If you do this during your test and you don't see a graph pop up, that should be an indicator to you, maybe I should change the mode. And if you change the mode, it should work. So let me go back to the calculator and we are going to type these in. So the first one is 2 over cosine theta. And where is theta? Nope. Nope. There it is. I am in degrees, so I'm going to make sure to change it to radians. Oh my gosh, so annoying. I deleted it again. Okay, 2 over cosine theta, and then press enter. So if you zoom out, this is basically just some kind of straight line. So let's try another one. How do I add a new graph? I don't even know. Oh, there we go. Now let me change cosine to sine and see what happens. So the next answer choice is 2 over sine theta. That just gives you a horizontal line. Okay, let me erase all of this. And now we're going to put, dang, where's the equals? Oh, now we're going to put 2 theta, which is the last answer choice. And as you can see, you get a spiral. D will be the correct answer for number 14. Number 15. An airplane flies east for 200 miles before turning 60 degrees south and flying for 100 miles. What are the magnitude and the direction of the airplane from its starting point? So go ahead and start by graphing a coordinate plane. And we're talking about east and south, so you need to know your compass. Some people remember it as never eat sour worms, never eat soggy waffles, never ever smoke weed. Whatever you need to remember your compass. And then the first vector, because there's 2 different vectors happening. The first one is flying east, so it's going straight in the east direction for 200 miles. And the other one is going 60 degrees south for 100 miles. So you got to put each of these in component form. So if I do the blue one in component form as the magnitude times cosine of the angle of direction. Now notice this is on the 0 degree mark. It's not going up, it's not going down, it's just staying there. So the angle is 0, comma 200 sine 0. Then for the orange, it's going to be 100, the magnitude cosine. Now you could do the angle of direction going all the way around. So you see that it's 360 minus 60. So it would be a positive 300 degrees. However, I've noticed that most of you guys forget to find the angle of direction and you always try to put the angle that's given in the question. If you see on the graph that the graph is going down, so notice that here the graph is going down, then if you want to use this value, you need to make it a negative angle, okay? So you could put negative 60 in here, but if you put positive 60, it's not going to work. Okay. And then when you are ready to find the resultant vector, you're going to add the cosines, you're going to add the sines, and that's going to give you the resultant vector. So let's go to the calculator. And notice that those angles, 0 degrees and 60 degrees, they're in degrees. So your calculator has to be in degrees. So I'm going to change my settings to degrees. And then I'm going to start typing. So we have 200 cosine 0 plus 100 cosine of negative 60 degrees. Press enter. Then we have 200 sine 0 plus 100 sine of negative 60. Press enter. This is giving me this exact answers, but it's fine. Your calculator will give you a decimal, but that's fine. Okay, so your x coordinate is 250. And then the other one, let me approximate it to a decimal. Hold on. Let me copy and paste it. And then I'm going to approximate it to convert to decimal. So it's about negative 86.6. Okay. Now you can figure out what quadrant this is in. So it has to be in quadrant 4 because you have a positive x and a negative y, and that's the only place where that happens. And you might be asking, why is that important? Well, at the very end, you're going to need to find the angle. And remember, if the angle is in the top 2 quadrants, you leave it alone. But if it's in the bottom 2 quadrants, you do have to do extra work to get the final answer. So that's why it's important to know that. Okay, now we're going to find the magnitude. And the magnitude formula is the square root of a squared plus b squared. So whatever you just got, you're going to put it under the square root and square them. Make sure that negative is in parentheses. Okay. Let's go back over here, and we're going to do the square root of 250 squared plus, I'm going to put this. In parentheses because it's negative. Paste. Oh, paste. It's being so annoying. Paste. Squared. And then enter. So the magnitude is about 264.6 if you round. Okay, so from there you can already eliminate two answer choices because the magnitude on these is not 264.6. So at least if you can get that far, you got a 50-50 chance of getting the correct answer. Now to find the angle, you're going to do A equals magnitude cosine theta, where A is basically the x, so the x from the resultant vector, which is 250. The magnitude is 264.6 cosine theta. Then you divide and take the inverse of cosine on both sides. And that'll give you theta. Okay, so let's go to the calculator. Inverse cosine of 250 divided by the answer. Copy and paste and enter. So you get 19.12 degrees. Now, that angle is not in quadrant 4. We had already agreed that it was in quadrant 4. So basically this 19 degrees is just saying that the vector is going down 19 degrees into quadrant 4. So it's about right here. And this angle, this little angle, is about 19.12 degrees. Now, that's not the answer choices we have. The reason for that is because these are going from south to east, south to east, south to east, meaning that you start in the first letter, which is south, and you go in the direction of the vector in the east direction until you touch the vector, which is right here. So we're looking for this angle. We have this one. We know this one is 19, but we got to figure out this long one. So in order to do that, we know the whole quadrant is equal to 90 degrees. So if you take this 19 degrees away from the 90 degrees, you'd be left with the actual angle that we want. So for that reason, we're going to do 90 minus 1912. And then so for the angle, you get 70.89, which rounds up to 70.9. So the answer is B as in boy. Okay. Number 16, which angle has a negative sine value and a negative cotangent value? So here you would use your all students take calculus to narrow down the quadrant. So if it's negative sine, it can be all, it can be sine, and it's negative cotangent, so it can be quadrant 3 either. So we're forced to be in quadrant 4. So basically you got to figure out which one of these angle measurements is in quadrant 4. So if you remember your unit circles, I'm going to draw 4 little circles for all of them. And I'm just going to draw the x-axis on them. You don't got to worry about anything else. Just keep it simple. And then remember that on this side of every single unit circle, you have 0 radians, pi radians, and then you go back to 2 pi radians. So if that's the case, you're going to match up the denominator and the numerator, because then what's going to happen is 7 and 7 cancel out, leaving you with just pi. So you're going to do that for all of them. Whatever the denominator is, you match the numerator. And then the other side, which is 2 pi, you just have to multiply the numerator by 2. So 7 times 2 is 14, 8 times 2 is 16, 6, and 10. And then you go and try to figure out approximately where would these angles be. So pi over 7, that has a coefficient of 1. So it's 1 right after 0, so it's going to be somewhere right here in quadrant 1, so it can't be A. 5 pi, that'll be somewhere here, maybe in quadrant 2. 4 pi, that's 1 more than 3, so it's going to be in quadrant 3, so these don't work. And 9 is 1 less than 10, so notice that this one is going to be right here in quadrant 4, so D has to be the correct answer. Now let's say that you have no idea how to do this, you don't know your unit circle, you don't know what to do. You're just going to need to find sine and cotangent of all of these angles and see which one gives you a negative combination. I'll do the actual answer just so you can see how to plug it in. Just know that it is very tedious to do this for all 4 answer choices. So if you have a way to maybe try to narrow it down, that'd be great. So go to the calculator, and the angles are in radians, so change the mode to radians. And we're going to start, it says negative sine. So sine of, and again, I'm only doing the correct answer. I'm not going to do all of them. So 9 pi over 5. So you see you get a negative answer. It's so annoying that it does it like this. I don't know how to change it. I'm sure it's a very simple way to make it not do that. But you get negative 0.5. So that's a negative sign. So that's already halfway done. That's good. Then you got a negative cotangent of 9 pi over 5. And you press enter. Again, it's negative. Now convert it to a decimal just so you can see it better. Negative 1.3. So when you did sine and cotangent, they both give you a negative. If you did these calculations for the other 3 answer choices, it might be a mix. It'll be a mix of positive, positive, negative, positive, positive, negative. But only the last one is negative, negative. And so that's why the correct answer is D. Number 17. In triangle ABC, the measure of angle A is 32, angle C is 110, side C is 750. What's the approximate length of side A? Notice that we have a pair, we have an angle and the side C. So when you have a pair, you can use the law of sines. So sine C over little c, you always start with the one you have the pair of, and then you set it equal to the letter that you're solving for. So we're solving for A. From here, you can plug in the numbers. So sine of 110 over 750 is equal to sine of 32 over A. When you have 2 fractions that are equal to each other, you cross multiply. So we have A sine of 110 is equal to 750 sine of 32. To isolate A, you would divide both sides by sine of 110. And so let's do that in the calculator. And this one is in degrees. I know it seems very tedious to go back and forth between degrees and radians, but be very mindful when you're working this out on the test. So we're in degrees because 110 and 32 are in degrees. Okay, so open up the fraction, and then it's 750 sine of 32 over sine of 110. Press enter. Oh, this is so annoying, but okay. Paste and then convert it to a decimal. You won't have to do this because your calculator just automatically puts it in decimal. So 422.95. Okay, and read the question because it says round to the nearest hundred. So that's the nearest hundreds place. If I had rounded wrong, there is no partial credit on the test. It's either it's right or it's wrong. So when you're done with your problem, just go back and double check that the rounding is correct. Don't get it wrong over a simple rounding mistake. Okay, number 18. Point P is rotated 210 degrees counterclockwise around the circle with a diameter of 20 meters. If the center is at the if the center of the circle is at the origin, which coordinates represent the location of P relative to the center? So when they give you the diameter is 20 meters, they are also giving you the radius, which is half of that, so it's 10. Now, the radius of a circle is basically from the center to the edge. So from there, that's 10. This is 10. This is 10, 10, 10, 10, 10, 10. All of these red lines are 10. Now, but I'm interested in this line particularly, so I'm going to put my 10 right there because it's the distance from the center to the edge of the circle. Now, if you think about the things that we have learned, the topic where they give you a radius and an angle measurement is polar coordinates. So they're basically giving you r and theta. They gave you r is 10 and theta is 210 degrees. So if they give you the polar coordinates, they want you to give them back the rectangular coordinates, and the equation for those are x equals r cosine theta, y equals r sine theta. And then you just plug it in. So r is 10, cosine is 210, y is 10, theta is 210. And then you would just go ahead and put that in the calculator. So 10 cosine 210, and the calculator has to be in degrees because 210 is in degrees. Mine is already in degrees, so I'm not going to change it. And then 10 sine 210. Okay, so it needs to be -5, square root of 3, and -5. And the only one that has that combination is A, as in apple. Yours is not going to give you the negative, it's not going to give it in square root format. It's going to give you a decimal. But then all you have to do is put this in the calculator and make sure that the decimal matches whatever you get as your answer. I don't know, this calculator I downloaded is very fancy and gives me the square root answer, which is cool. But anyways, moving on to number 19. Owen's house is 12 blocks from the library, 8 blocks from the school. The library is 9 blocks from the school. What is the approximate measure to the nearest degree of the angle between the path from Owen's house to the library? Blah, 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 blah. Okay, so I'm going to label my side. So Owen's house, I'm going to label as O. So if this is big O, then across from him has to be little o. Okay, I'm going to label the school S, and across from there will be little s. And then finally, across from angle L will be little l. So remember, whatever you're solving for has to be the first letter. So if you're solving for O, you got to start with O. Okay, so we're going to do O squared is equal to S squared plus L squared minus 2SL cosine big O. Okay, so we know O is 9 squared, S is 12 squared, plus 8 squared minus 2 times 12 times 8 cosine O. For the law of cosines, it's very helpful to just put this straight into NSolve, because if you don't use NSolve, then you have to simplify everything individually, then you have to subtract, then you got to divide, then you got to do the inverse, and there's a lot of room for mistakes. So on your calculator, do menu, and then algebra, and then you're going to do NSolve, so the first one. And then you're going to type this exactly how you see it. So 9 squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times cosine of O. And then after you do that, you need to do comma, and then you need to tell the calculator what variable you want to solve for. So since we're solving for O, you need to do comma O at the end. And then you press enter. My goodness. It is so complicated. Okay, let me just, I don't know why it's so fancy. Let me convert that to a decimal and see what we get. Oh no, I did something wrong. Oh, I'm using the wrong thing. That wasn't NSolve. This is NSolve. Okay, let me try this again. 9 squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times cosine O, and then again do comma O, and then press enter. And you get 48.58. But the question does say round to the nearest degree. So the nearest whole number, so angle O would be 49 degrees. Again, make sure you're looking at the rounding thing. You don't want to mess up because of that. And if it's the law of cosines where it's a lot of steps, just rely on end solve. It'll save you a few minutes of time. Even if you know how to do it, it'll just save you time to do the ones that you don't know how to do that well or you need more time on. Okay? Moving on to number 20. Two forces act upon an object as shown. What is the approximate magnitude of the resultant force? So I'll do one of these in blue and I'll do the other one in pink. Okay, so we got to do each of these in component form. So we got the magnitude of the angle, and you switch cosine and sine, and then you do the same thing for the second vector. Now again, we're going down 27 degrees, so this has to be a negative angle. Don't forget the negative if you're going down instead of up. Okay, and then we're gonna add them up. So you're gonna add the cosines, you're gonna add the sines, and you're gonna get the resultant vector. So let's go do that on the calculator. I'm already in degrees, but if you're not in degrees, make sure you are, because 20 and 27 are in degrees, not in radians. So we're gonna do 15 cosine 20 plus 12 cosine of negative 27. Press enter. Oh my gosh, I'm gonna throw this stupid thing away. I'm kidding, I'm not. But it's so annoying. I should have figured this out before I started, but I was too late. Now I put approximate to fraction. Don't hate me. I'm almost done. I'm sorry. Enter. So it's 24.78. I'm gonna do the same thing. 15. I'm gonna put this whole thing in parentheses and do this all in one step. 15 sine of 20 plus 12 sine of, wait, did I do it wrong? Oh no, that's fine. Okay. 12 sine of negative 27, and then I'm gonna approximate it to a decimal already. So 15 sine 20 plus 12 sine negative 27, enter. And that's what you get. So we're gonna come back to the notes, the packet, and the x coordinate was 24.787, and the y coordinate was negative 0.317. Okay, now we're looking for the magnitude. That's what the question is asking. Find the magnitude. So the magnitude is equal to square root of a squared plus b squared. And a is the x coordinate, b is the y coordinate. And make sure it's in parentheses. Okay, so let's go back over here. And we're going to do the square root of this squared plus parentheses this oops, oh man, I messed it up. It's also hard to do this in like touchscreen. And then I'm gonna square it. Make sure the square is still under the square root, and then press enter. As you get 24.78, which is approximately 24.8. So B would be the correct answer. Okay, number 21. If A is equal to that, B equals that, C equals that, what is 1/3 of A minus 3/2 of B plus 2 of C? Okay, so what you're going to do is just write the scalar on the outside, and then you're going to fill it in with the actual vector that it corresponds to. And I'm going to color code it just so you guys can tell them apart. Okay, so this is C, B, and A. Okay, when you have a scalar times a vector, all you need to do is distribute that into every part of the vector. Okay, so 1/3 times -6 is -2, times 12 is +4, and times -9 is -3. Now the thing with the orange one is that there's a minus. So you have two options. Either you bring down the minus and you only distribute the 3/2, or you distribute -3/2, and then when you come down, it'll be a plus. I personally like this way better. Just change it to an addition problem and distribute that negative. So that's what I'm going to do. So since it'll be a positive because I'm putting the negative into the vector numbers. So this will be -3, 24, and -27. And then multiply vector c by 2. So that's 56, -28, and 6. Now what you're going to do to get the final answer, you're going to have a three-part, like 3 vector things. You add all the first numbers of each, and then all the second numbers of each, and all the third numbers of each. So the first numbers are -2, -3, and +56. Then you do it again for the middle numbers. 4 plus 24 minus 28. Then the third numbers, -3, -27, +6. And so you basically just simplify all of these in the calculator, and what you get is A as in apple. So the biggest thing to remember is that negative, if you distribute the negative, make sure you make it an addition problem. If you don't distribute the negative, you can bring the minus down, and then you would just subtract them instead of adding them. It's up to you what you want to do. Number 22. A hyperbola has vertices at 2, -5, and 2, +3. The slope of one asymptote is -1/2. What is the equation of the hyperbola? So I'm going to graph it. So 2, -5, and 2, 3. And those are the vertices. So if they're the vertices, that means they're on the major axis. So that means that this is going to be a vertical hyperbola. Okay. Now, if you notice between the vertices, so from one vertex to the next vertex, that's a distance of 2a. Okay, so from vertex to vertex is 2a. So if you're going, so the x doesn't change, but the y does. If you're going 3 units this way and 5 units that way, if you add them up, that's a total of 8. And if you cut that in half, that would be 4. So the semi-major is from the center to the vertex, from each vertex. So if you do -5 plus 4, then you end up at -1. -5 plus 4 is -1. Or you can start at 3 and then do -4. So 3 minus 4, either way you get -1. Okay, so the x coordinate doesn't change, but the y coordinate is 2, -1, like we just talked about. And that's the center. Okay, so we have h and k and we have a, we still need b. Now they give us the slope of one of the asymptotes is -1/2. Now in class we didn't actually do this, but it is in the formula chart. So if you go to the hyperbola section and it's vertical, so make sure you're looking at the vertical side, and the vertical side is over here. There is a section for asymptotes. So we're going to be using the vertical asymptote for hyperbolas, which is y minus k equals plus or minus a over b times x minus h. Okay, so I'm going to rewrite that really quick. Now that seems scary and terrifying, but the only thing you have to worry about is this part right here. None of that other stuff matters. That I circled is the slope of the asymptote. So you can have either positive a over b or negative a over b. Okay. Obviously this one is negative, so I'm gonna match it up with the negative one because I don't know the positive one. So if that makes sense. So I'm going to do negative a over b is equal to negative 1/2, because that's the slope. Now we already know that a is 4, so I'm going to plug that in here to further simplify. So negative 4 over b is equal to negative 1/2. Okay, now if you recall, to solve when you have two fractions that equal to each other, you cross multiply. If you forget how to do this, you can just put it in and solve and it'll do it for you. Negative 4 times 2 is negative 8. Negative 1 times b is negative b. Take the minus away, so b is 8. Okay, and now we have all the letters we need to write the formula. So for a vertical hyperbola, we're right here. We're going to do y minus k, and k is negative 1 over a squared, a is 4, minus x minus 2, which is h, over 8 squared, b squared. Okay, so we're going to simplify this. Y minus negative 1 is y plus 1. 4 squared is 16. X minus 2 squared. 8 squared is 64. And so the only answer choice that matches this would be answer choice B, as in boy. Okay, and that's it, you guys. That's the second half of the review packet. I hope you guys learned something, reviewed something made some more sense than it did previously. And if you have any other questions, please reach out to me and I will get back to you as soon as I can. Bye, you guys. Good night.